Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 4 from section 1-4 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to apply formulas. Alright, so we're just doing a little extra example with different formulas that we see in the real world and using it to solve a problem. I find this one is actually a very relatable example. Because it has to do with cooking, and I'm a big fan of cooking. And when I go to find recipes online, if they're from a country other than America, it puts their oven in Celsius, and my oven doesn't have that form, so you kind of have to convert it to Fahrenheit. So this is a nice example for something that is applicable to your own life. So this says, according to Tio's bread recipe, he should bake the bread at 190 degrees Celsius for 30 minutes. His oven measures temperatures in Fahrenheit. So in what temperature in Fahrenheit should he set his oven? I mean, in reality, could you go to Google and say, convert from Fahrenheit to Celsius? Yes. Is that what I do? Yes. But here's the calculation on how you would do it by hand. So if you look at the oven, which has his bread of bacon in there, they actually give you the formula. So Celsius is equal to 5/9 EU fractions times Fahrenheit minus 32. Alright, so what we want to do is we want to get the F, the Fahrenheit, by itself. Now usually when I see a number that's like right in front of some parentheses, I'm like, distribute! Distribute it! I like freak out, start barking, I don't know. But when your variable that you're trying to isolate is in the parentheses, if you distribute to it, you're just going to have to divide that back out later. So if I were distributing, I'm creating an extra step that I have to undo later. And so even though there's like a puppy dog in the back of my head saying, send that over, distribute, do what you can, I'm not gonna. Instead, I'm going to divide by 5/9. Now remember, fractions are strange. You probably in middle school learned about copy dot flip or keep change flip. I don't know what else they teach in middle school these days, but when you have a fraction, the way that you remove it, the inverse operation, is to multiply by what's called the reciprocal. That's the flip part. So what I'm going to do, because that 5/9 is being multiplied, I'm going to multiply by 9/5. Because 5 times 9 is 45, 9 times 5 is 45, and 45 over 45 is 1. And so that's what causes it to be an inverse operation. That's very handy in Algebra 1, just so you know. So the 5/9 and the 9/5, they cancel out, leaving me with the Fahrenheit minus 32. And the inverse operation of that subtraction would be to add. I couldn't have added before, right, because that 32 was trapped inside the parentheses. And so removing that 5/9 freed it up to not be trapped anymore. Like Shrek freed Fiona. It's beautiful. Alright, so there's our equation. Notice they're very similar to each other. You should end up with numbers that look a lot alike when you do that, okay guys? So if I have something in Fahrenheit, I could just plug in the Celsius temperature, and wham bam, thank you ma'am, it tells you what your Fahrenheit should be. And so that's actually what I'm going to do here in green. And I'm also going to zoom in a little bit, because I didn't leave myself very much room, and it was terrible planning on my part. My bad, that's what I get for you guys watching free videos. Alright, so Fahrenheit is equal to 9/5 times your degree in Celsius. So the bread recipe says 190 degrees Celsius. And then you'd add 32 to whatever that number is. So remember, you want to simplify the multiplication and division before you can add. So I need to find 9/5 of 90, or 190. Ew. Now there's a couple ways you could do this. Okay, I'm going to do what I usually do. Some people do 9/5, like they take 9 and divide it by 5, and whatever that decimal is, they multiply times 190. That's fine. I tend to divide out the fraction number first because then I'm dealing with smaller numbers that I might be able to deal with in my head. So 190 divided by 5 is 38. And then I would do 38 times 9. Well, I couldn't do that in my head, but it's 342 according to my calculator. And then we're going to add that 32 there to simplify it. And so when I do that, the degrees Fahrenheit is 374. Y'all, I'm going to warn you, when you get out there in the real world, I've never had a stove that can go to 374. It would be 375. Don't worry, that 1 degree doesn't really matter. So he would need to set his oven to 374 degrees Fahrenheit. I think I spelled Fahrenheit right. I'm a math teacher, not a science teacher, and you guys can judge the public education system here in the US. Alrighty. So now the try it says the high temperature on a given winter day is 5 degrees Fahrenheit. What is the temperature in Celsius? Alright, now I play video games, which I don't think I've ever mentioned on YouTube, but I mention it to my students all the time. And I play video games with a lot of people from other countries. And so when I'm complaining about the temperature, I usually convert it for them because everybody else uses Celsius. So this is the calculation you would do. So if you know the degrees in Fahrenheit and you want the Celsius to come out, you should use the version of the equation that has the Celsius by itself. Okay? So I'm going to say the Celsius equals 5/9 times our degrees in Fahrenheit, which is 5, minus 32. Now, my head says, distribute. Do it. Distribute it. Don't distribute. You guys can simplify those parentheses and you don't have to multiply as much, okay? So 5 minus 32 is negative 27. And so now what I'm doing is I'm going to use mental math here because I'm lazy and I don't want to reopen my calculator, which I closed because I don't have foresight. So I can do the negative 27 divided by 9. All right, that is negative 3 times 5 is negative 15. So 5 degrees Fahrenheit is the same as negative 15 degrees Celsius. So then I put in here the habits of mind. Most of my videos don't have habits of mind because I created them before I intended on using those. Don't judge me. But it says, how are the variables in temperature conversion? Like, how are they related to each other? So how are the F and the C related? Well, because they're both describing a temperature. This one's kind of a straightforward answer. Alright, there we have it, y'all. That is how to apply formulas. Until next time.